Let's look at the 4-stroke and 2-stroke petrol engine cycle. What is a stroke? It's the movement of the piston from top dead centre to bottom dead centre. Calling an engine 4-stroke means its engine cycle has 4 strokes. A 4-stroke petrol engine uses internal combustion, so those 4 strokes must include the 5 key events common to all internal combustion engines: intake, compression, ignition, power and exhaust. Let's look at a simplified model. The intake stroke starts with the exhaust valve closed, the inlet valve opening and the piston at its highest point, top dead centre. It starts to move down, increasing the volume above the top of the piston. This makes pressure inside the cylinder lower than pressure outside. This higher outside air pressure forces air-fuel mixture into the cylinder. The piston reaches bottom dead centre, the inlet valve closes and the intake stroke ends. Both valves stay closed as the piston leaves bottom dead centre. The piston moves up, squeezing the air-fuel mixture into a smaller and smaller volume, which compresses it. That makes its temperature rise and that makes combustion easier. Just before the piston reaches top dead centre, the next key event occurs: ignition. Burning, expanding gas generates the force to push down the piston. This is the power stroke that drives the engine. The piston now moves from bottom dead centre to top dead centre. The exhaust valve opens and the piston pushes out the leftover gases. Let's look at the cycle operating. Intake takes in air-fuel mixture. Compression squeezes the air-fuel mixture into a smaller and smaller volume. Ignition, the mixture under pressure is burned. Power, burning expanding gases push the piston down, creating a power stroke that turns the crankshaft. Exhaust, the piston moves upward, forcing burned gases from the chamber. All 5 events occur in this order in each of the engine's cylinders. Let's look at the cycle of the 2-stroke petrol engine. Calling an engine 2-stroke means its engine cycle has 2 strokes. As in a 4-stroke engine, a stroke is the distance from top dead centre to bottom dead centre. The piston moves up the cylinder from its lowest point, bottom dead centre, compressing air-fuel mixture already in the combustion chamber. As it rises, the top of the piston covers the exhaust port and the transfer port. This is a third port or passage between crankcase and cylinder. The bottom of the piston uncovers the inlet port. At the same time, the rising piston is increasing the volume of the crankcase below the piston. Pressure in there falls until it's less than outside air pressure. This pressure difference forces more mixture into the crankcase. As the piston reaches top dead centre, mixture already there ignites, and expansion of gases starts to drive the piston downward. The piston moves down. The bottom of the piston covers the inlet port as the top of the piston uncovers the exhaust port. Opening the exhaust port starts the scavenging process. It releases the pressure above the piston and burned gases escape. At the same time, closing the inlet port means the descending piston is compressing the air-fuel mixture in the crankcase. The top of the piston uncovers the transfer port. Increased pressure in the crankcase forces fresh air-fuel mixture up through the transfer port into the cylinder, replacing the burned gases, and the cycle starts again. This intake system is called a piston port system because the piston acts as a valve to cover and uncover the ports. This intake system uses a rotary valve. The crankcase has a hole open to the crankcase chamber and a rotary valve cover attached to the carburetor. The rotary valve is mounted on the crankshaft between the crankcase and the valve cover. As the crankshaft turns, the rotary valve rotates with it, opening and closing the inlet port as it does so. Some 2-stroke engines, such as outboard motors, use an intake system with a reed valve. It's a small, flexible metal plate that covers the inlet port, and it can be attached to the crankcase or to the inlet port. It opens and closes automatically, according to changes in pressure in the crankcase. The two-stroke engine makes only 2 strokes, one up and one down for each time it fires. That's only 1 revolution of the crankshaft for each cycle. Compare this with a 4-stroke that needs 2 revolutions of the crankshaft for each engine cycle, and only 1 power stroke for each 4 engine strokes. Let's run the cycle again. The piston moves up the cylinder. The top of the piston covers the exhaust port, the bottom uncovers the inlet port. Air-fuel mixture enters and circulates in the sealed crankcase below the piston. The piston rises and compresses the mixture above it. A spark plug ignites it and it burns. Pressure from the expanding gases pushes the piston down in a power stroke. The top of the piston uncovers the exhaust port and lets exhaust gases escape. The bottom of the piston covers the inlet port and forces air-fuel mixture up into the now open transfer port. The piston reaches bottom dead center and the crankshaft forces it back up to repeat the process. Notice which events occur above the piston. Compression of the air-fuel mixture into the combustion chamber, combustion for the power stroke, and scavenging of the exhaust gases. Notice the events that occur below the piston. Intake into the crankcase, pre-compression of the air-fuel mixture in the crankcase, and the transfer of mixture from the crankcase through the transfer port and into the combustion chamber.